Hi everybody, we are going to continue with our notes in our interactive notebook, but today we're going to be focusing on dilations that are reductions. So right now what I want you to do is I want you to highlight something for me. It says here, draw a dilation of quadrilateral ABCD with vertices A012, B99, C126, D33 using a scale factor of 1/3. So let's go ahead and circle this. Notice our scale factor is now between 0 and 1. And when it's between 0 and 1, that, as we learned in our very first video, is known as a reduction. A reduction just means, and I'm typing this out for you, that an object is actually going to get smaller. And we know that the scale factor has to be between 0 and 1 in order for that object to get smaller. And that's what we're going to see working through this figure today. First thing I want you to do is I want you to write down the original coordinates of A, B, C, and D, and then we're going to look at using a scale factor of 1/3 to find our image. First thing I want you to do is with point A, go ahead and write your A prime, because we know that's going to be the next point. And I want you to look at the original coordinates of A. We have 0 and 12. Now if our scale factor is 1/3, what that means is we're going to be taking each coordinate and multiplying it by that scale factor. So we're going to write down times 1/3. And we're going to do that with both the x and the y coordinate. So if 0 times 1/3 is multiplied, we know that we once again just get, oops, sorry about that, hold on. Anything times 0 is just 0. So that one's pretty easy to figure out. But when I take 12 and I multiply it by 1/3, and you can go ahead and do that in a calculator if you need to, it means the same thing actually as dividing by 3. So if I take that value of 12 and divide it by 3, or multiply it by 1/3, I get the value of 4. So that will be my first image point. I am then going to go ahead and do that with points B, C, and D. And because it's a reduction, remember we're multiplying by a scale factor that's between 0 and 1. So 9 times 1/3 to get B prime is actually 3. And once again, that second coordinate, y, is also 3 because 9 times 1/3 is 3 once again. Now let's go ahead and look at C. We have 12, 6. Oh, that's a terrible looking arrow. Sorry about that. So to get to C prime, we are once again going to take 12 and multiply it by 1/3 to get 4, and 6 times 1/3 to get 2. We're going to do the same thing with our final point D. So go ahead and draw your arrow going to D prime. And 3 times 1/3 is 1. And once again, 3 times 1/3 is 1. So D prime will be located at 1, 1. Now we're going to go ahead and we're going to label those points. Remember, the new figure better be getting smaller, and it should be getting smaller by 1/3 the size. So A prime is at 0, 4. Oh, let me just change my color here so you can see it. So 0, 1, 2, 3, 4. So this will be A prime. B prime is now located at 3, 3, and that's a little bit confusing because it's in the same location as D, but that's okay. C prime is now at 1, 2, 3, 4, 2. I think I did my B prime wrong, didn't I? Oh, no, I didn't. 3, 3. And last but not least, D prime is now at 1, 1. So we'll label that D prime. I want to make sure the C prime over here is kind of out. There we go. Now when I go ahead and connect those points, you will notice that my image is 1/3 the size of the original. The angle measures stay the same, but the line segments change their lengths, and that's why it gets smaller. These figures are known as similar figures. They are the same shape, but they're a different size, so they can't be congruent. So remember, our new shapes are now similar. Let's take a look at example number 4. In example number 4, our original figure is at negative 5, 10, 5, 0, and negative 5, negative 5. Now what they've done for us is they've given us our image points. So let's go ahead and write those in. A prime is now at negative 1, comma 2. B prime is now at 1, comma 0. And C prime is now at negative 1, comma negative 1. Well, we might be asking ourselves, what did I multiply? Because remember, a scale factor is what we're looking for, and scale factors are always done by multiplication. So what did I multiply negative 5 by to get to negative 1? I'm not really sure. And if you don't know, you can take the image, and I want you to write this down here. I'm going to do it in a different color so you can see it. I want you to take the image point, sorry about my handwriting, over the original. And I want you to write this down because this is a ratio you're going to be able to use to find the scale factor all of the time. And I'm sorry, my G over here looks so terrible. That is a G. There we go. So it's image over original. So my image point is always my prime notation right here. So if I'm going to take negative 1, which is my x-coordinate, and I'm going to put it over my original, which is negative 5, the x-coordinate. Well, what's a negative divided by a negative? Hopefully you're saying it's a positive. And the simplified form of that is 1/5. So guess what I'm multiplying by each time? 1/5. 1/5 is now my scale factor. But we have to see if it works. Oh, I just noticed my B is wrong over here. Let's just check that. B prime we said was at negative 1, 0. There we go. Sorry about that. Okay, so now let's go ahead and try another image point. Image over original, that ratio will always give us our scale factor. So if we go ahead and we look at B to B prime, my image point is going to be 1 for the x-coordinate, and the x-coordinate on the original is 5. And there it is, 1/5. That's my scale factor. Let's try it one more time for C. So remember, C at negative 5, negative 5 goes to C prime at negative 1, negative 1. So I'm going to do my image point, which would be negative 1 over my original for the x-coordinate, which is negative 5. A negative divided by a negative is a positive, so it simplifies to 1/5. So every single time we are taking these first original coordinates and we are multiplying them by 1/5 to get our prime notation. So our scale factor is 1/5. Now here's my question. Does it make sense? Well, we know that when objects get smaller, they're being multiplied by a fraction. Did I get a fraction for my answer? Yes. But I want to show you or prove to you another way that I know my image is 1/5 the size. Remember my ratio image over original. If I were to go ahead and find a beautiful, beautiful point, A, and connect it by a straight line to another point. Remember, it always has to be straight. It can't be on a diagonal. And I count the distance from A to C. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's my original. AC is my original length, and that is 15. So I'm just going to go ahead and put that on the bottom of my ratio because that's where my original goes. Now my image from A prime to C prime is 1, 2, 3. So I'm going to go ahead, I'm going to put A prime to C prime, just so you know where I'm getting that unit distance from, is 3. If I simplify 3/15, guess what I get? 1/5. I still get that same scale factor of 1/5. And that proves, just by looking at the images themselves, that this smaller image is 1/5 the size of the original. Go ahead and try some practice problems, and hopefully you can go back and forth between finding the scale factor and going and dilating to get a reduction. Have a great day.